geometry student, to the homework help video, page 502. Let's go ahead and get started with these problems. Numbers 9 through 12, the directions say to find the indicated measure for circle A. So here we go. Let's take a look first of all at number 9. Let's find the measurement of ED. Now, please notice something, students. Notice here's the center, and notice the distance from the center right here to ED is congruent to the distance from A to the segment BC. They are the same. Also notice we have a right angle here, okay? So listen to me carefully. Anytime that we have chords, chord ED and chord BC, anytime we have chords that are equidistant from the center, those two chords will always be congruent. So notice that BC and ED are both equidistant from the center. So because of this, we know that BC is congruent to ED. So BC is 10, ED is also 10. Number 10. Okay, now notice, students, first of all, they want to know the measurement of CD. Now, first of all, we know CD is a diameter because it passes through the center of the circle. But to just review for a second, also notice that CD is a chord, and notice that CD is a chord in such a way that it's perpendicular to EF, okay? And notice also that CD is bisecting EF because this segment here is congruent to this segment here. Anytime a chord is perpendicular to another chord and it bisects the other chord, that chord is a diameter. Now, we already knew CD was a diameter because A is the center of the circle and CD goes through A, but still, nonetheless, just wanted to review that with you. CD is the diameter. Now, the radius is 3.6. So if AB is 3.6, then AD is also 3.6, and CA is also 3.6. So from here to here is 3.6. From here to here is 3.6. Add those two together, and you'll get 7.2 for a total of CD. Alright, arc BD is 40 degrees. So BD is 40 degrees from here to here. Alright. What is the measure of arc CD from here to here? Well, these two arcs are congruent, so the measure of arc CD is 40 degrees also. Now let me show you how I knew that, okay? Anytime that we have a chord that is perpendicular to another chord. Sorry, students, I had to pause the video for a second. Anytime a diameter is perpendicular to a chord, which it is, we know this is a diameter because it passes through the center, okay? And it's perpendicular because of this right angle symbol right here. So anytime a diameter is perpendicular to a chord, please listen to me carefully, students. It bisects the chord, so this segment is congruent to this segment, but also bisects the arc. So this segment here is congruent to this, or this arc here is congruent to this arc here. So if BD is 40, then DC is also 40 degrees. Alright, number 12. What is the measure of arc EC? EC from here over to here, okay? Now we know that BD is 170 degrees, okay? From B to D is 170 degrees, okay? We know that. Now watch this carefully. Notice something here, students, about these two chords. Would you please watch this carefully, students? Notice this chord here is made up of a segment that has one mark and two marks. Notice this chord here is also made up of two segments that have one mark and two mark. That means these two chords are congruent. So if two chords are congruent, we learn that their minor arcs are also congruent. So BD, notice BD is the arc of BD, segment BD, okay? And notice that chord CE is the chord for arc EC, okay? either the congruent segment or arc, depending on what we're dealing with. For example, on number 19 here, or 13, we're dealing with arc AF. So what arc is congruent to arc AF? Well, look students, here we go. Here's a diameter that is perpendicular. A diameter right here that's perpendicular to a chord. So it bisects the chord and it bisects this big arc right here. So AF is congruent to AB. Arc AF is congruent to arc AB. Alright? And that would be letter C. Alright. Arc FE. Okay, well here's FE right here. Got it, there's the arc. And here's the chord that made that arc. Now notice that chord has two tick marks, 2 marks. Well look, 2 slashes. Well notice this segment here has 2 marks also, which means this arc here has to be congruent to this arc over here. Remember, if 2 chords are congruent within a circle, then their corresponding minor arcs are congruent. So the arc that's congruent to FE is BC. BC, which would be letter F, arc BC. Alright, let's continue on. Let's take a look at number 15. Number 15, segment FH. Okay, now look, here's segment FH, students. We just talked about this. Look, I have a diameter right here. So that diameter is perpendicular to a chord. So if it's perpendicular to a chord, that's going to bisect FB. It's going to cut FB in half. So FH is congruent to HB. So FH is congruent to E, which is HB, or BH. Same thing. Alright, let's continue on to number 16. Number 16. EG, segment EG. Well, let's see. Here's segment EG right here. Now, notice again, students, we have a diameter right here, okay? And that diameter is perpendicular to a chord. Anytime a diameter is perpendicular to a chord, it's going to cut the chord in half. So this segment is congruent to this segment. So EG is congruent to GC or CG. Letter A, GC. Alright. Alright, moving on now, students, to number 17, arc ED. Okay, well here's arc ED. Once again, students, very redundant, but here's the diameter. It's perpendicular to this chord right here. So it bisects the chord, but it also bisects the arc. This big arc right here bisects it. So ED is congruent to DC. ED is congruent to DC. Letter B, DC. Alright, and then lastly, segment CD. Segment CD. Well, students, think about this now. Okay, students, I'm back. My computer kind of crashed there, so I recovered everything, but here we go. Okay, now we're talking about segment CD, okay? And so now think about this. Segment CD, right here, okay? Now, look at this triangle here. Look at this triangle here. First of all, we know they have a congruent angle because when 2 lines are perpendicular, it forms 4 right angles. So if this is a right angle, we know this is a right angle, and we know this is a right angle here. Secondly, these 2 triangles are sharing a side. Okay? So we got right angles. Then we have the 2 triangles sharing a side. We already know that this side here is congruent to this side here. We stated that earlier up here, that EG is congruent to GC. Okay? So we have side, angle, side, congruent to side, angle, side. So these 2 triangles are congruent. If these 2 triangles are congruent, then all of their parts are congruent. So if all of their parts are congruent, then CD right here has to be congruent to ED. Okay? So CD congruent to ED, which is letter D. Alright? Letter D. Okay, moving on. Hope that makes sense. Number 21. Okay, let's prove this real quick here, guys. This is a pretty simple proof. Let's see if we can't do this rather quickly. Alright, here we go. We're given radius BP bisects angle APC. So we're going to So step one, students, we'll put our statements over here and our reasons over here, and let's go ahead and get started. Number one, we're going to list out our given, okay? So list out your given. Got it? Now, I want to state that we have angles 1 and 2 that are congruent. So I'm going to state that angle 1 is congruent to angle 2. Alright? I'm going to state that because that's the definition of an angle bisector. Okay? Definition of an angle is bisector. Now, for step 3, I'm going to state this. Now watch carefully. The measure of angle 1 equals the measure of arc AB. That's true, guys. The measure of angle 1, if it's 45 degrees, equals arc AB, which would be 45 degrees, okay? So I'm going to state that. I'm also going to state that the measure of angle 2 equals the measure of arc BC. That's true. And of course, the reason would be arc measure equals central angle. Arc measure equals central angle. Now, we should be able to do a little substitution here for step 4, okay? The measure of angle 1 equals the measure of angle 2 are congruent. So where 2 is right here, I'm going to put angle 1 because 1 is congruent to 2. So where 2 is right here, I'm going to put angle 1. Okay, so I'm going to do that right down here in step 4. So the measure of angle 1 equals the measure of arc BC. Okay, so where this is, I put 1, and of course this is simply going to be substitution. And then, lastly, and we're finished. Notice that I have the measure of angle 1 equals the measure of angle B, so I can substitute this in for the measure of angle 1 right down here, okay? So that's what I'm going to do. So where the measure of angle 1 is, I'm going to put the measure of arc AB equals the measure of arc BC, okay? Now, that's good enough for me. I have no problem with that substitution. If you want to write it one more step and put a congruent symbol in there, like they have right up here, congruent, so put congruent. I have no problem with that at all. I'm just going to leave it like that. Those 5 steps are definitely sufficient for me. Okay, that's definitely good enough for me. Alright, on a test or a quiz, if you said they're equal, same thing as congruent, no problem. Alright, number 22, we're given that arc AB equals CD. Let's go and put that on the circle. So this arc is congruent to this arc. Prove that AC, this arc here is congruent to this arc here, BD. Okay, so really the plan of attack is actually pretty simple. I mean, look guys, this arc here is congruent to this arc here. That's given to us right here. Well, you're adding the same thing to both arcs. You're adding BC to AB, and you're adding BC to CD. So you're adding the same arc to both of them. So yes, it's no wonder that this arc here will be congruent to this arc here. It makes total sense because you're adding the same arc to both of them. So my plan of attack is going to be to first of all state that arc BC is congruent to arc BC, reflexive property, and then make some substitutions and see if we can figure it out from there. Okay, so here we go. So let's first of all make a little bit of space here, which is always helpful when you're dealing with proofs. So there we go. And let's see what we got here. Statements and reasons. Alright. Let's see, number 1, we've got our given. Now, number 2, right off the bat, I'm going to state this. Arc BC is congruent to arc BC, okay? And of course, that's the reflexive property, okay? Now, watch what I do next. This is like segment addition. It's arc AB plus arc BC equals arc AC. So AB plus BC equals AC, the entire thing, okay? So AC. Now I'm going to do the same thing here. I'm going to put on the same step BC plus an arc is equal to the sum of its two adjacent arcs. So I think is how it was worded, but that's what we've done here. Arc addition, okay? Now we can make some substitutions here. So let's go ahead and do that. In your given, you have AB is congruent to CD. Got it. Right here. AB is congruent to CD. So see this CD right here. I'm going to put AB in place of it. Alright. So number 4, I now have BC plus AB equals BD. Okay, so where this is CD, I simply put this. That's it. Nothing else changed. BC is still BC, BD is still BD, and of course it's going to be substitution. Now really you shouldn't substitute with congruent symbols. You should wait till you have equal signs, but I've not really been that strict on that all year. It's totally fine what we're doing here. Okay? Alright, now let's go ahead and continue on. Notice, students, right here what I'm underlining is BC plus AB. Notice right here what I'm underlining, BC plus AB, or AB plus BC, same thing. So I can use substitution. This whole expression here equals AC, so I can pick up AC and put it in for this expression right here. So, for this expression right here, I'm going to put AC. And that should be done. That should take care of the proof right there. Arc AC is congruent to arc, or equals, if you want to, equals arc BD. And that would be, again, substitution. Alright. Okay, let's continue on now to number 24. We're going to rotate a chord AB 180 degrees clockwise from about P to form chord A prime B prime. Sketch the result, then explain why you have a rectangle. Okay, no problem. We're going to take this point here. We're going to rotate 180 degrees. We learned this a couple chapters ago, I believe 1 or 2 chapters ago. So we draw this here. Then we're going to rotate 180 degrees, which of course would put us in a straight line going this direction here. So A gets rotated all the way to here. Alright, so that's A primed. Now B is going to be the same thing. I'm just going to go ahead and put the chord right here. There's B primed right there. Alright, so let's go ahead and connect. These lines, and now explain why A, B, A prime, B prime. Look at my pen, guys. A, B, A prime, B prime. A, B, A prime, B prime is a rectangle. Well, sure, not too difficult. First of all, we know this is a diameter. So we could also draw another diameter. Okay, going through the center. And we could say, the two diameters equal each other, and so if you have a quadrilateral in which the two diagonals equal each other, then you know right away it has to be a rectangle. Alright, if you have a quadrilateral in which the diagonals equal each other, alright, has to be a rectangle. Alright, number 26. If you see a flash of lightning, in seconds later you hear thunder. Then the lightning struck is approximately 1/5 in miles from you, and is referring to the seconds, of course. So in other words, if you hear, if you see lightning and then hear the boom 6 seconds later, you just take 6 times 1/5, which gives you 6/5, and then you know approximately how many miles away it was. 1 1/5 miles away. That's what this formula means. Now, sound travels at a rate of about 1,100 feet per second. Explain why the 1/5 rule gives the approximate distance between you and the lightning. It's very obvious, guys. It's 1,100 feet per second is how fast sound travels, okay? So, it goes this many feet in 1 second. A mile has 5,280 feet. Okay? So, 1,100 is just about, not exactly, but it does say approximate. 1,100 feet is about 1/5 of a mile. Think about it. If you take 1,100 and multiply it by 5, you will get 5,500, which is a little bigger than 5,280, but you still get my point. 1,100 is just about 1/5 of a mile, so that's why we multiply the seconds by 1/5. Okay? Every second is 1/5 of a mile because every second is 1,100 feet. Okay? Now, number 27. You see a flash of lightning. 6 seconds later, you hear the thunder. Describe the position, the possible location of the lightning. Sure. First of all, we know that we're going to take 6 seconds times 1/5. That's what you always do. And 6 times 1 is 6. 1 times 5 is 5. So we're looking at approximately 1 1/5 miles away from you is where the lightning struck. Now, they want to describe the possible location of the lightning. Sure, no problem. It's going to be a circle. I mean, you're here, right? And you know it's 1.5 miles away. So it could be any location on this circle, depending which way you were looking, of course. Alright? But the location of the lightning striking where it struck at is 1.5 miles approximately from where you're at. So make a circle, and that's all the possible locations going around that in a circle. Alright? Okay, number 29. The directions for 29, 30, and 31 say to. Let me turn over there real quick, students. It says to L is the center of the circle. So in the next 4 problems, L will be the center of the circle. We're going to find MP. So we're looking for MP. Now students, please follow along carefully, okay? First of all, notice I have a chord within a circle. Got it? And then, even though the whole diameter is not being drawn, we understand that if I did draw a diameter, it would fall in this line right here, because this line is hitting center L of the circle. So, we basically have a diameter that's perpendicular to the chord. So, if we have a diameter that's perpendicular to the chord, that means that it bisects that chord. So this segment here is congruent to this segment here. Got it? So I am going to call this segment here X. And this segment here also X. Got it? So moving on. Now, I want to establish that point first. Now next, we have a right triangle right here, a big right triangle. And within that right triangle, we're drawing an altitude from the right angle to the hypotenuse. There's my altitude. Well, we learned when that happens that the length of this lake here is the geometric mean of this little segment and the entire segment going across there, which of course the entire segment of MN would be 2x because we have x plus x. Okay, so we learned this a while back that this lake right here, right here is the geometric mean of those two numbers or variables. So 4 is 4 is the geometric mean. So I'll put 4 in the bottom and I'll put 4 in the top. Okay. Now the other two numbers or unknowns would be x, which is the little segment here, and then 2x, which is the entire segment all the way across. Okay. So here we go. Cross multiply 16. Cross multiply 2x squared. Divide both sides by 2. 8 equals x squared. Take the square root of both sides. The square root of 8 equals x. Now you can simplify the square root of 8 down into the square root of 4 times 2, which is 8. We know the square root of 4. Cross it off. Put a 2 on the outside. And there's your answer. 2 square root of 2. 2 square root of 2. And I don't think the directions said that you had to write your answer in radical form. So I would accept this as an answer, or decimals also. Either way would be fine. Alright, number 30. Okay, they want us to find the length of MP. Now students, we're going to do something here really quick. We should know by now. Notice we have a 60, 60, 60 triangle. Congruent, congruent, congruent. Notice we dropped an altitude straight down like that. Okay, now we've done that before with our special triangles. Anytime you have a 60, 60, 60 triangle and you drop an altitude down, you're left over with a 30, 60, 90 triangle. We know this angle here is still 60. We know this is going to be a right angle right here. This angle up here was 60. We cut it in half, so this is going to be 30. Alright, now we're trying to find MP, which is this length right here. MP, from here to here. We know this length right here. The hypotenuse is 12. Now here's what we learned about 30, 60, 90, 30, 60, 90 triangles. Hope you guys remember this. We learned the shorter leg is always across from the smaller angle. So here's 30. Go straight across. This is your shorter leg, okay? Here's 90. Go straight across. This is going to be your hypotenuse over here. Okay? Here's 60. This will be your longer leg over here. Now, we're trying to find MP, or the longer leg, alright? Well, here's what we know. If you remember what we learned, what I taught you, is that the hypotenuse is always twice as big as the shorter side. So if the hypotenuse is 12, then the shorter side right here is 6. Then we learned that the longer leg is always the shorter leg times the square root of 3. So the longer leg is always the shorter leg times the square root of 3. What is the shorter leg? 6. So the longer leg, right here where SL is, you're going to put a 6. So the longer leg is very simply 6 square root of 3. Okay, that's pretty simple. Okay, as long as you know your shortcuts there. Alright, moving on to number 31. Number 31, okay? They want us to find the length of MP. Alright, MP. Alright, here we go. First of all, notice that we have concentric circles, and this line here is going to be perpendicular because it's a point of tangency right here. And this line here will also be perpendicular because this is a point of tangency right here. Now, please listen carefully, students. Anytime that you have a diameter, which this is basically a diameter if I would draw the whole line out, okay? Anytime a diameter is perpendicular to a chord, it bisects the chord, okay? So, if this length right here is 5 TS, then SR is also 5, okay? Now, also we've learned that if a chord like this chord here and this chord here, if two chords are equidistant from the center of the circle, then we know the two chords are congruent. Well, this is a radius of the little circle. This is a radius of the little circle. So we know those two lines are congruent. So if they're congruent, then we know that chord, now listen, chord TR is equidistant. Chords TR and MP are equidistant from the center. Thus that makes TR, because chord TR and chord MP are the same distance from the center of the circle, that makes chord TR congruent to chord MP. Okay? Now, notice I have 5 plus 5, which is 10. So MP then, 5 plus 5 also has to be 10. Same thing. Alright, number 32. Last problem was asking me the same thing. It's going to be identical all over again, so I'll be really quick, okay? You've got a diameter here. If you were to draw it all the way out, it's a diameter, and it's perpendicular to the chord, okay? Which means it bisects the chord in half. So if SR is 3, then ST is also 3. So the whole length of TR is 6. TR is 6. Now notice once again, we have equidistant chords. Chord TR and MP are the same distance from the center. This line here is the same as this line here. How do I know that? Because they both have a mark through them, okay? Mark right here and a mark right here, okay? So TR is equidistant from the center as MP is, okay? So that means TR is congruent to MP. So if TR is 6, then the measure of MP must also be 6. Alright, there we go. Alright, I hope this homework help video has been a help to you. If you have